The fifth talk is PrivateJobMatch, a privacy-oriented deferred multi-match recommender system for stable employment, and it's going to be presented by Amar.
Is it on? Okay, there we go. Cool. So, hello, I'm Amar Saini, and I'm presenting PrivateJobMatch, a privacy-oriented deferred multi-match recommender system for stable employment. The other authors of this paper are Florin, Rusu, and Johnston. We're all affiliated with UC Merced in the United States. Okay, so a brief outline. We're just going to jump into some details of job recommender systems. We're going to dive into some of our proposed work, multi-match deferred acceptance algorithms, go over some results regarding simulation, and end with a conclusion. So here's what your standard job recommender system architecture kind of looks like. There's lots of different types of input. Most of you guys know there's explicit data, such as having candidates build user profiles, providing lots of personal and private information, such as job history, education history, personal and professional traits, and so on. You can commonly see this on Indeed, LinkedIn, and this is part of the reason why some people don't have LinkedIn, such as the previous presenter and also my brother. It's too much data to provide. The other kind of data that typically involves is implicit data, such as tracking user activity, such as what they click on, how long they spend on websites, and so on. And typically, users aren't even aware that they're being monitored in these kind of platforms. So the main thing to take away here is that when you have all this data, you typically do some kind of feature selection, throw some cloud filtering, content-based filtering on it. You might even run into the cold start problem, all that jazz. And the main thing this architecture or the system tries to optimize is the best candidate recommendations and the best job recommendations. But the problem is they're optimizing it independently of each other. Like this gentleman in the tan shirt mentioned after the second presentation, this is a two-sided recommender system. We want to make sure that the recommendations are reciprocal, as in both sides are satisfied, candidates and employers. So with that, we propose PrivateJobMatch, where we don't even need any implicit information. We just get minimal explicit information, specifically rankings, preference rankings. So this system is actually driven by the deferred acceptance algorithm, and it provides stable matches as output. And an example of the input we need here would just be having a candidate rank the jobs they're interested in from most preferred to least preferred, and have employers rank the candidates they're interested in from most preferred to least preferred. This is the input, and the output of the system will be multiple sets of stable matches between these candidates and jobs that we can use as recommendations. And this will help deal with a two-sided problem here. All right, some of the contributions we make just incorporating the deferred acceptance algorithm into a recommender system so we can use the stability of matches as a way to deal with the two-sided recommender system. And we only require a minimal amount of explicit data. There's no need to gather explicit or implicit data. We also implemented some machine learning techniques such as LMF, where you can optionally use this to enhance and infer new preferences to get different kind of match output on our multi-match deferred acceptance algorithm. We ran some experiments over both real and synthetic data to help prove that this system will stabilize the job market. And we deployed this on a real application called EconMatch with real users and found that this system offers better results for maximizing job market stability in the sense of minimizing job vacancy and the number of jobless candidates. So some of the applications of the deferred acceptance algorithm, another word for it is the Gale-Shapley algorithm being used to solve the stable marriage problem. This has been seen to be used on dating websites as well as employment and medical fields. A variation of this algorithm is known as the Roth-Pairings algorithm, and it's been used in the domain of college admissions where you have one single student that can be admitted to multiple different colleges. And what we're proposing here is a multi-match deferred acceptance algorithm where we have a many-to-many matching as output. So this is just a brief example of what the DA takes as input and what the output here would be. So as input, you have candidate 1. His first preference is job number 2, his second preference is job number 3, and his third preference is job number 1. Likewise, the employers will be ranking the candidates. That's the input, goes into the deferred acceptance algorithm. The output here would be a single set of matching pairs between the candidates and jobs. All right, this is a problem because it only provides a one-to-one match output. And recommender systems kind of offer multiple choices, not just one, right? So that's the main problem with the regular version of the deferred acceptance algorithm. And the second thing is you have to have an equal number of candidates and jobs, which is definitely not feasible. And the ranking matrices here must be dense. Okay, and the example I just showed you, every candidate ranked every single job in the market. And that's not going to happen in the real world. Not every candidate will apply for every single job there is in the world. So the way we got past that would be to use a multi-match deferred acceptance algorithm. And this allows us to find multiple one-to-one stable matches. So the second set of tables on the right side there on the figure, boxed in red, that's an example of a more real-world input. And you can see here, like the second candidate and third candidate don't have a second rank or a third rank because they only applied to one or two jobs. This is something we would see in the real world. And the output of a multi-match deferred acceptance algorithm would be multiple one-to-one matches. And also here, note that when we go up on the figure, so if you look at the first set of tables, that's the output of a multi-match deferred acceptance algorithm. And you can see that sometimes there's an NA, as in there was no match for a given round. And the problem is the data sets are too sparse, and there was just a lack of preferences. There's something we can really do about that. Except we could optionally apply collaborative filtering, where we can infer new preferences like we did on the third row, the third set of tables, where we throw the input preferences into some low-rank matrix factorization, and we can generate and infer new preferences, and then use those in the new multi-match deferred acceptance algorithm, and get new matches. The problem with that is these matches are actually inaccurate because they don't have any correlation with the original input preferences. So to get the best accuracy and to minimize the number of unmatches or vacancy, we combine the two, and that's what makes MMDAA does. We take the matches from the very top, the first run through the MMDAA, and we take the matches after the second run of the MMDAA when we use LMF, combine the two, and we get the green box at the very bottom, which is the optimal set of matches that we can use for recommendations. So to ensure that the system will help stabilize the job market, we decided to measure vacancy. We basically wanted to see what would happen if employers were to offer jobs to candidates based off of the direct preferences as it is done now in the decentralized market, versus what would happen if employers used their MMDAA match results to offer jobs to candidates. And we found that it definitely minimizes vacancy on both the employer side and the candidate side, on both synthetic and real data that we collected. The green line here is the decentralized market. The black line is using the MMDAA, which is no LMF involved. And the blue line at the very bottom that minimizes vacancy on all the data sets and across candidates and employers. It incorporates both results from the original multi-match deferred acceptance algorithm and an LMF variant to get the best vacancy. Short conclusion, we adapted the deferred acceptance algorithm into a recommender system to find reciprocal recommendations to make both sides satisfied. It's privacy oriented because we don't have to have users build their entire user profile and provide all this personal and private information. There's no implicit data required. We only require the few preference rankings. And you don't have to use collaborative filtering, context filtering. You don't have to worry about running into the cold start problem. The mixed MMDAA, as I stated earlier, combines the results from the first proposed algorithm, the multi-match deferred acceptance algorithm, along with its variant, the LMF version, to get the best results that minimize vacancy, along with some other metrics that are included in the paper. And we deployed this in an application with real users called EcoMatch, and this was focused at careers in the field of economics for academia, using aeajobs.org. It's a website for economics. We had candidates go on the site and make accounts. We had employers go on the site and make accounts. They rank each other. We got the data, fed it through our system. We fed it through a simulator that would see what would happen if we were just to offer jobs based off the direct preferences they gave us. And we found that it minimized vacancy. So the code is on GitHub. And if you want an extended report, you can look at my master's thesis. Thank you.
Questions back there?
It was a really nice talk. I had a couple of questions. One was regarding the stable matching, and you mentioned that you are actually able to get stable matching, particularly in applications like job recommendations. The reward is actually quite delayed, particularly things like confirmed hires might actually happen a few months down the line. So how do you evaluate stable matching, particularly on real data sets? And another question I had was about the fact that you're having stable matchings, it makes sense till a user or a job runs out of the market, particularly if they're matched. How do you take that into account as time progresses, basically?
Right, so I also talked to LinkedIn about this kind of stuff, and one of the things they brought up is this is kind of, you can't really use this in a moving market. It's kind of like a one-time run after you get all the data and just run a matching algorithm. And that's one of the problems with it, is that you have to have kind of like a static set of jobs and candidates, but one way to deal with it is just run it periodically multiple times and just have different results for different days. That's part of the future work we're looking into, is how to deal with moving candidates and jobs under the system. What was your first question? I couldn't hear it.
The first question was about how you measure stability, because many of these metrics are long-term to some extent.
Yes, so I didn't go over the metric for stability here, but to ensure that the matches are actually accurate with respect to their input preferences, to see that they're getting aligned based off what they like on both sides, we use displacement, and that was taught in the paper as well as in the thesis.
Thank you.
Yeah.
Question right here?
I have the mic, I guess. Thanks for the presentation. I was wondering if you've looked into how the algorithm performs across different user groups, so comparing maybe men and women or different levels of skill sets, if there's any kind of unfairness. Because it seems that these are quite high stakes recommendations, right? So we want to avoid any kind of bias.
That's a very good question. We have the data for it, but the experiments we ran were just on the numbers itself, but we should take into consideration other factors.
Yeah, thank you. So in many of your slides, you mentioned minimal explicit data. I would like to know, so if we have a large data set, how can you come up with this minimal explicit data?
A large data set of people?
Yeah.
In the sense that they'll be ranking jobs, but most of the fields should be sparse because they only rank the jobs they apply for. And I mean minimal explicit data as compared to having users build an entire profile on LinkedIn or Indeed, which some would consider a lot to do on the user side.
Okay.
Any other questions over here?
Nice talk. Thanks a lot. Seriously impressive that you've done this as part of your master's. Hats off. Have you thought about constraint relaxation here? So the scenario being that the employer might be looking for the wrong criteria, or the employer might be too strict in the criteria that they're setting. A bit of the converse of the employee maybe not setting a complete profile, but making sure that you have partial matches.
Partial matches. One thing we did try is, I'm not sure if this directly answers your question, but we did encounter some things like, what if the candidates rank the jobs and the preferences that they want, but the employers didn't rank the candidates back or just don't have any interest in them. Our simple, naive solution was just to shuffle and put them at the back, but we didn't consider how to deal with like loosening constraints.
I think that has implication for the diversity issue as well, right? So there might be minorities, not necessarily by protected characteristics, but there might be minorities that aren't getting into the rankings for not fulfilling certain criteria. So in terms of actual applications of that, I think that might be something to look into. But thank you very much.
Thank you, that's a good insight.
We have time for one more question.
Thanks for the talk. I wonder if this system is even legal in the European Union, as this is an automatic system which will lower my chance of getting a job based on like some action of someone else who applied to the same position, and this might be like discriminatory use of algorithm. Did you talk with some lawyer about legality of actually running this?
Well, yes, if your employer is racist and he puts you at the very bottom of his preference list, then yeah, you probably would be matched with someone else. But yeah, under the assumptions that people rank fairly, would be fine. So to answer your question, if it's legal, I have no idea yet. Yeah.
Thanks.
Good
Take the
point.
speaker again.